Hi everybody, today I'm going to teach you hypothesis testing, this time two population. Let me remind you what we learned so far related to hypothesis testing. So we learned that if we have one population or one sample in Excel, we need to build a dummy sample in order to fool the Excel and use the t-test to sample unequal variance, right? Remember, we needed to have two samples, but we didn't have one. Therefore, we built one dummy sample, putting some zero there to fool the Excel. Remember, for hypothesized mean difference, we use that number that was appearing in the question. For example, if it was saying that we are claiming that the grade for a student is higher than certain number, then that certain number was our hypothesized mean difference, right? So now today we are going to learn about two different populations. I'm going to start with the example and a story as always. Let's assume that we want to know whether or not the average weight between two different species of turtles is equal. So this is the main question for the researcher for so many years. They wanted to know that if two different species of the turtles have the same weight or not, because it would help them when they want to treat them if there is something wrong with them with the doses of the medicine. So if they would assume that their average weight is equal, it helps them a lot in terms of injecting the drug on their bodies, right? So we want to test that, and this is a big question for the researchers. Given that the researchers cannot go to the ocean and take the test of every single turtle to measure all the turtles in the world to see that if they are actually have the same amount of the weight for the two different species of the population of the turtles, right? So it's very time consuming, very costly. They need to hire so many people to go catch these turtles, measure their weight, release them. So, it's different and it's difficult. Therefore, we need to have a hypothesis and test that and see that if these two different species have the same weight or not. We also want to be sure that we are 95% confident that after we check this test, our result is correct. So therefore, we have this significant level called alpha equal to 0.05. Remember, if I'm 95% confident, my significant level would be 100 minus 95%, which is 5%, or 0.05, right? So significant value is important because at the end, when I calculate the probability, I compare it with the significant value. If the probability that I found is bigger than the significant value, I should accept the null hypothesis. If it is smaller than the significant value, I should reject the null hypothesis, right? So now I know all this information. I just remind you all of these. Let's go and see what's happening for this example. So we have two samples now, and one sample size is for the first species of turtle and has 40 observations. Their average weight is 300 and their standard deviation is 18.5, right? And then the second sample has 38 observations in it. Their average weight is 305 and their standard deviation is 16.7. Obviously, these two samples, their average weight is not equal. Also, remember that we would say a good sample size is a sample size that has at least higher than 30 observations. So both of these samples are good because one of them is 40, one of them is 38. So they are both higher than 30 observations in them. So that's a good sign. Now let's see how we can build our hypothesis. In real world, we start our first step by gathering the information. But in our class and in our example and our practices and questions that I'm giving to you, you can start with the second step, which is defining your hypothesis. So I would say very simple, start very, very simple, right? I would say our null hypothesis assumes that these two populations means average of their weights are equal. And then second hypothesis or Alternative hypothesis assumes that they are not equal, as simple as that. One says is equal, the other says is not equal. I also can show the null hypothesis with h index n or h index 0. And then alternative could be h index a or h index 1. Now, I want to show you how we are actually calculating the t. Remember, we did the same thing for our one sample population. This time is for two sample population. We need to learn how to calculate the value of t and how to calculate the probability manually to appreciate using of Excel. So first, I'm going to show you how we can calculate it manually. And of course, this manual calculation doesn't come to the exam because it's time consuming, but it's important to learn how to do that. So we are using the standard deviation, which is combination of the standard deviation of these two samples. We call that pooled standard deviation, and here is the formula for that. So S square, standard deviation square called variance. When I take the root square of that is a standard deviation. But before that, when it's S square, is variance. So the variance is sample size number 1 minus 1 multiplied by standard deviation or variance of the sample 1 plus sample size 2 minus 1 multiplied by variance of the second sample, divided by sample size 1 plus sample size 2 minus 2 because I had two samples, right? That's why minus 2. So I just plug all the information that I have. In order to have a pull the standard deviation, I need to take the square root of that. Therefore, I put the square root. So you see here, I'm gonna draw this square root goes all the way here. This goes all the way here and then divided by this number. So sample size 1 was 4t minus 1 multiplied by standard deviation number 1 was 18.5. The square of that plus 38 minus 1 multiplied by 16.7 square of that divided by sample size 1, which is 4t, plus sample size 2, which is 38, minus 2. So this is my pooled standard deviation. And this is my step 3. Step 4, after I calculate the pooled standard deviation, I need to calculate the t value. So t value is average of the first sample minus average of the second sample divided by pooled standard deviation multiplied by, so again, square root of 1 over sample size 140 plus 1 over sample size 2, 38, the square root of all of this. So the number that is given to me is value of t, which is minus 1.2508, right? So I'm gonna use in a step 4 the Excel in order to calculate the probability associated with this t value, right? So in Excel, you can easily type equal to t dot distribution. Remember, we had norm distribution for normal distribution probability. Here, because we are using t, we are using t dot distribution, and we need the two tails. Remember, in that table, we were always checking two tails probability. Here, we want that. So that's why we say dot 2t, which is stand for two tail, and is asking us what is your t value. So for t value, although I collect that calculated became negative minus something, in t value here in Excel, I always can use the absolute value of that. Instead of negative, just put 1 point, the number, right? Ignore the negativeness of that and just put 1 point, 2508, comma, is asking you what is the degree of the freedom. So degree of freedom is this number, is sample size 1 plus sample size 2 minus 2. So that is my degree of freedom, 76. Put it there. And then I calculate the probability now. Hit the enter. So when we hit the enter, we calculate the probability. So the probability in that case would be smaller than significant value. or even bigger than a significant value. We don't know how much it is, so we can calculate that. And looks like after I put the enter here, the number that I calculate is something big. Therefore, the alpha, which is 0.05, is smaller than what I calculate. The probability that I had was bigger than significant value. I do not reject the null hypothesis, or I accept the null hypothesis. And null hypothesis was saying that the weight of these two different species of the turtle are equal. So do not reject or accept the null hypothesis because the probability that I calculated is bigger than 0.05. Now let's start with another example. So in this example, suppose that we have two different samples. Both of these samples have the same sample size. Both of them are 7 observations in them. And then the average of sample size 1 is 240, with the average of the sample size 2 is 210. Standard deviation of number 1 is 5. Standard deviation of number 2 is 6. And telling us build your hypothesis, and the significant value is 0.05. So what I need to do is first build my hypothesis. Two populations are equal, and then alternative says they are not equal. Calculate the pooled standard deviation by having this formula. So remember, this is my S square. I need to take the root square of that, root square of this number, remember? Root square of this number, it's 5.52, right? After I calculate the root square of that, I calculate the t-value, which is the average of number 1 minus average of number 2, divided by 5.52 multiplied by root square of 1 over 7 plus 1 over 7. So the answer for t-value is 10.16, right? So make sure that when you are using these calculations, when you are using any calculation in either calculators or Excel, make sure that you put a big parenthesis. Oops, how can I undo this? There is no way to undo that. So big parentheses around here, you see? So because if you don't put the parentheses, what happens is the calculator or Excel is just dividing the result of this by this number and then multiply the whole thing by this one. So that's why you need to make a big parentheses around what is in denominator in order to avoid any mistake like that. And now I calculate the t-value. I already have the pooled standard deviation and everything. So now I need to calculate the probability for the t-test. So I would type equal to t distribution to dt, to t. So I put the t-value, which is 10.16, comma, I need to calculate the degree of freedom, which is 7 plus 7 minus 2 is 12, and then calculate the probability. So this probability is 0.01, which is smaller than 0.05. Therefore, I should reject the null hypothesis and say the population means are not equal. Simple as that. So now I have one practice for you, very similar to this. I want you to do this practices yourself and share your answer with me. That's very similar. I just changed some of these numbers. So that was all for the t-test to population.